Here is my second video going through the Specialist Maths Exam 2 Section B for this year. So let's have a look at the extended response question. Okay, question 1, we want to sketch this graph. Interesting to see the using the notation y of x, but I'm going to define it as f of x equal to 3x, x to the power 3, plus x plus 2. And then I want to label the asymptotes with equations, the turning point, the point of inflection, give the coordinate of the point of inflection correct to 1 decimal place. So if you have a look at f of x here and change the viewing window accordingly. For example, make this -4, make this 4. Probably I'll use 0.5 for the scale, and this one is 0.5 as well. And put a 2 here, also put a -2 here. So basically, you see there is a turning point and also a vertical asymptote. In the long run, horizontal asymptote, just menu analyze graph maximum. 0.75, analyze graph inflection. 1.68, 0.596, which is 1.7, 0.6. So you'll be able to, let's say, label a turning point here. Notice this number should be exactly 2 decimal places, or let's say 1,3/4, exact value, and 1.7, 0.596, 0.6. So should be here. And also, it should cut through here, roughly here. Show some good change of concavity. And in the long run, I suspect horizontal asymptote is needed. Vertical asymptote here. Let's draw that properly. Doesn't work very well. Okay. And also, if you try to gauge an accurate point, like this is 2.5, slightly below 0.5. Also here, it's at -2, it's right in the middle. So I would say, roughly speaking, here, also here. So make sure you carefully get an accurate sketch of this graph, okay? So basically that is the graph you should present on your physical exam booklet. I'm also marking down 0, 0 here. So hopefully I included everything. Then we can move on and have a look at the next part. The region bounded by the graph, the coordinate axis, and the line x equals to 2. Rotating about the x-axis to form a solid revolution. So it's here to here. Okay, something like that. Definite integral. Keep the volume. So we say v equals to pi integral 0 to 2. Square everything, 9x squared divided by x cubed plus x plus 2. Whole thing squared, dx. And I want to evaluate this volume. Pi times integral 0 to 2, f of x, whole thing squared, dx. So we'll get, let's say, 2.29. Find equation of vertical asymptotes of the curve given by this thing here. So we have another function, it's different. So let's call this g of x. G of x is 3x, x to the power 3 minus 5x plus 2. And if you quickly confirm with the graph g of x, there are 3 vertical asymptotes. So for the 3 vertical asymptotes, obviously this x cannot cancel anything from the denominator, like a cancelable factor. Therefore, what I'll do is just solve denominator equal to 0 for x. So I'll be able to get, let's say, 3 of them. The question says the equations, so I just write x equals to minus root 2 minus 1, x equals to root 2 minus 1, and x equals to 2. I just need the vertical asymptotes. I don't need to have, let's say, y equals to 0. Also, you should write x equal as 3 separate individual equations. Now we also consider a family of curve y of x, so I'll just name this one as h of x. H of x is assigned to 3x divided by x to the power 3 plus a times x plus 2. The case where it has a stationary point, so I'll define dh of x as shift minus derivative h of x. We'd like to find, let's say, dh of x equal to 0 and y equals to h of x for the coordinate of the stationary point. So we can see if I use h dash of x equal to 0 and y equals to h of x. Then my x equals to 1, y turning point equals to 3 over a plus 3, where a is not equal to negative 3. So this is the answer I want. The question just wants the y coordinate of p. And for a given value of a, the graph has no stationary point for this value here. So if I take, let's say, a equals to minus 3, sub that into the function and get the vertical asymptotes, let's see what happens. So you can see this is a simplified equation, and I try to use the expand button, comma x. So eventually you get 3 parts with the x minus y as a repeating factor. Therefore, h of x equals to minus 2 over 3 times x plus 2 plus 2 over 3 x minus 1 plus 1 over x minus 1 whole thing squared. Therefore, the vertical asymptotes will be x equals to minus 2 and x equals to 1. Only these two. And for a given value of a, the graph will have a point of inflection at x equals to find a value of a. So I'm trying to evaluate h double dash 2 equal to something and equal to 0. Then I define ddh of x is shift minus x dh of x. And then I try to use ddh of 2. So you actually get a negative 3, 5a minus 24 divided by 2 lots of a plus 5 to the power 3. Therefore, a equals to 24 divided by 5. So that's it. And I think that's a fair 2 marks question. Let's move on. Question 2, complex number question. Sketch the circle here. This circle is x squared plus y squared equals to 2 squared. Whenever you have z times z bar, that's x squared plus y squared. So basically, it's just this circle over there. Make sure you fully trace the circle, okay? Like a radius 2. And next thing is you want to show that the equation may be expressed as y equals to root 3x. So basically, you will get square root x squared plus y minus 2 squared. You don't have the I squared. Be aware of that. You just need the imaginary part. And x minus root 3 whole thing squared plus y minus 1 squared. Okay, and then x squared plus y squared minus 4y plus 4 equals to x squared minus 2 root 3x plus 3 plus y squared minus 2y plus 1. Eventually, you can cancel out the x squared and the y squared from both sides. Then this 4 and the 3 and the 1, they will also cancel each other out. And eventually, you get minus 4y equal to minus 2 root 3x minus 2y. And adding 2y to each side, you get a minus 2y equals to minus 2 root 3x. Therefore, y equals to root 3x. And notice that if you have tangent theta equals to root 3, the gradient, the angle theta must be 60 degrees or pi over 3. Therefore, if you want to sketch this full line, it's along this thing here, okay? 60 degrees relative to the positive x-axis. And make sure you fully cover this line, not deflecting away from this ray here with 60 degrees angle. And then you want to find the points of intersection of the curves defined in part A and B1, expressing the answers in Cartesian form. A, B are real numbers, real part, imaginary part. So the point of intersection between the line and let's say the circle, let's call this Z1. You can see this is obviously 2c pi over 3. And this is Z2 equals to minus Z1, that is 2c from here to here. So that is like minus 2 pi over 3. And obviously, the x value for a value is 1, and the y value or b value is root 3. This thing it will be minus 1 minus root 3i. So actually, I showed my working on a diagram. Alternatively, you can write the explicit equations like x squared plus y squared equals to 4, and y equals to root 3x. Eventually, you get 1 root 3 and minus 1 minus root 3. But remember, you have to write the complex number for 1 plus I times root 3, and z2 equals to minus 1 minus I root 3. Okay? So that's pretty much what you need for C1. And next thing is label this point. Yep, I already labeled them on the diagram. So that's done. And consider the point P and Q labeled in other Argand diagram below, Argand plane. A ray originating at point P, so it's an open circle, going through or passing through Q, it's like that. Now just notice, this is 60 degrees. This is also 60 degrees. This ray has an angle of rotation, I suspect, 60 degrees, parallelism. So this is also 60 degrees, but it's actually a minus pi over 3 in terms of the direction. Therefore, this is the point of reference. Our z0 in the ray is 3 over 2 plus I times 3 root 3 divided by 2. And the angle theta must be in radian measure, not in degree. Therefore, it's minus pi over 3. Lastly, we want to find the area of the minor segment bounded by this thing here. It's called here. And then, yeah, it's just applying the segment formula. A segment minus segment equals to half times radius 2 squared times pi on 3 minus sine pi on 3. So eventually, it's just like, okay, 2 times pi over 3 minus root 3 divided by 2, I suppose. So you get a 2 pi over 3 minus, hold on a second. Actually, bear with me, not a 2. I'm getting so used to the number 2 here, which is not the case. Because this circle has a radius 3 now. I need to remind myself. So actually, this is a 3 here. So you should get, let's say, 9 over 2 times pi over 3 minus 9 over 2 times root 3 over 2. So actually, that gives you 3 pi over 2 minus 9 root 3 over 4. In that case, your C value may well be 3 over 2, and D value is minus 9 root 3 divided by 4. Okay, this is one possible method. Another possible method is using integration, but I don't think it's awfully useful. For example, you could say y line equals to, the gradient is negative root 3 as it has a negative 60 degrees, x minus 3 over 2 plus 3 root 3 over 2, using the reference point originating from point P, and a y semicircle equals to r squared minus x squared. That's the top half of the circle. So the area equals to from 3 over 2 up to 3. So from here to here, and upper curve minus lower curve, okay? Upper semicircle minus the straight line. So you actually get, let's say, y semicircle minus y line dx. You can try to use that with your CAS calculator, I suspect. We call it y r of x is assigned to minus the square root of 3 times x minus 3 over 2 plus 3 over 2 times square root of 3. And you have ys of x is assigned to square root of 9 minus x squared. And you can set up an integral 0, 3 over 2 to 3, and y s x minus yr of x dx. Yep, exactly the same answer like what I calculated by hand. So that is another possible method you could adapt. Okay, complex number question down. The tank initially contains 5 kilograms of dissolved in 3,000 liters of water. So this is the question is Q. So that's Q naught equals to 5. 3,000 liters of water, the initial volume is 3,000. And salty water that contains 0.1 kilogram salt per liter. So that's the concentration of inflow. And I can figure out the concentration, initial concentration is 5 divided by 3,000. That is 1 out of 600. And C inflow equals to 1 out of 10, which is 60 out of 600. Okay, by considering concentration, explain whether the quantity of salt in the tank increases with time. Yes, it increases with time, or in the long term as time goes by, because concentration of inflow equals to 60 out of 600, which is greater than 1 over 600, equal to the initial concentration. So the water will become more and more salty. I shouldn't be using that phrase. Using the proper chemistry terms, you should say more concentrated, but it's just getting more and more salty, or we can say the brine is getting more and more concentrated, etc. Now, this one is a lovely differential equation question in terms of mixing concentration problem. Q is the quantity of salt in kilograms in the tank at time t minutes. So we have a total rate of change of the salt in the tank equals to the rate of inflow minus the rate of outflow. The next thing is the rate of the inflow is concentration inflow times dV dt inflow minus concentration outflow times dV dt outflow. It is important to recognize, okay, concentration in is 0.1 kilograms per liter multiplied by 20 liters per minute minus, at any time, the mass is Q, mass or the amount of salt. And initially you have 3,000 liters of water. Each minute you're running in 20 liters, and each minute you also run out the tap, 20 liters out. Therefore, it's going to be a 0 times T, 20 minus 20, and multiply by the outflow. So eventually, 0.1 times 20 equals to 2, minus 20 divided by 3,000. That'll be Q divided by 150. Eventually, when you combine the two terms, it will be 300 minus Q divided by 150. Okay, so that's how you're going to show this problem. But you have to show the explicit, I believe you have to show some working like that and get to the answer, okay? It's basically everything. Next thing is using Euler's method with a step size of 15 minutes, find Q30, the approximate quantity of salt in the tank after 30. So now we're dealing with T naught equals to 0, Q naught equals to 5. And let f of Q, which is a gradient function, differential equation, 300 minus Q divided by 150. Because there are 2 marks, your T1 equals to 15 minutes, your Q1 equals to Q naught plus the step size times f of Q naught, which eventually give you 5 plus 15 times 300 minus Q, that is 295 divided by 150. So you can get some number here, 5 plus 15 times 295 divided by 150. So you get a 34.5. And then T2 equals to 30, and my Q2 equals to Q1 plus step size still 15 times f of Q1, which will be 34.5 plus 15 times 300 minus 34.5 divided by 150. So you have that number plus 15 times a fraction, 300 minus that number divided by 150. So you get a 61.05. The question says correct the two decimal places. Therefore, you just write it as two decimal places, nothing else. You can quickly use the Euler's command to do 300 minus q divided by 150, comma t, comma q, comma, curly bracket, 0 up to 30. Initial amount is 5 and step size is 15. Yep, getting exactly the same answer here. But because this question says using Euler's method and there are 2 marks allocated, I would say on the safer side, you need to write your formulation and the calculation procedures, okay? Rather than just quoting, let's say, hey, this is 5, 34.5, 61.05, okay? Solve the differential equation. I mean, use calculus. Use calculus doesn't mean you can use your CAS calculator. But to be honest, there are multiple ways doing that. So what I'll do is separate the variables. So firstly, I would separate it like 1 over 300 minus q dq equals to 1 over 150 dt, something along this line, and integrate both sides. Next thing is you're gonna get log e of 300 minus q because it has a negative sign, and a c equals to 150 t. And then q equals to 5, t equals to 0. So you have minus log e of 295 plus c equals to 0. And your c value is log e of 295 with a positive sign in the middle, in the front. And then you can combine the two log terms. For example, log e 295 divided by 300 minus q equals to 150t. And then you have 295 divided by 300 minus q equals to e to the power 1 over 150 times t. Then, if you want to save a bit time, eventually I would resort on my CAS calculator. See what happens. So this is the solution. Q equals to 300 minus 295 e to the power that, okay, e to the power minus 1 over 150 times t, okay? Of course, this is just one method. There are other possible methods. Well, I'll probably show you some. For example, if you try to use, let's say, a definite integral, it is possible, but in principle, very similar to this one. Like you could also write a 5 here, q here, and a 1 over 300 minus u here du equals to t equals to 0 up to t and 150. Well, you can still use du here as long as you don't repeat the t, okay? And then you'll be able to get log e of 300 minus u. Well, the reason why I don't put a negative is because I'm going to put a 5 here and a q here. Switch the limit. Then this bit will be 1 over 150t. So you actually get log e of 295 divided by 300 minus q equals to 1 over 150t. So this is also a valid calculus method. Alternatively, you might want to say, I know a small group of our students will be doing UMAP every year. Well, if you look at, let's say, from part B, I suppose, this equation is dq dt plus 1 over 150q equals to, let's say, half, something like that, if I'm not mistaken. No, actually 2, bear with me. This is a 2 here. And the next thing is integrating factor mu equals to e to the power integral 1/50th, 1 over 150 times dt. This method is called integrating factor method. You get e to the power 1 over 150t. And therefore, you can multiply this e to the power 150, 1 over 150t, both sides. For example, you get an e 1 over 150t times dq dt plus 1 over 150 e to the power 150t times q equals to 2. The reason why you multiply the integrating factor both sides is simply because now if you set this as u, this is your dv dt, this is your du dt, this is your v. So you can actually recover a product rule. For example, d dt e to the power 1 over 150t times q as a function of t equals to 2e to the power of that. And integrating both sides, you get e to the power 1 over 150t times your required q of t equals to 300 e to the power 1 over 150t at c. And then if t equals to 0, q of 0 equals to 5. You get a 5 equals to 300 plus c, which leads to c equals to minus 295. So your q of t is going to be 300 e to the power 1 over 150t minus 295 divided by e to the power 1 over 150 times c. And this one simplifies to, let's say, the required answer, okay? Of course, this is a very edge case, I would say. I don't believe within the confinement of Unit 3 for specialist maths at a VCE level, you are required to do that. Of course, for those of you who want to pursue higher level of mathematics, there are other methods. For example, I still recall more than around 15 something years ago, when I was doing this in my university, yeah, you can write the differential equation like that, dq dt, or actually, let me just write the Leibniz notation or Newton's notation, the dash notation, I would say, q dash of t equals to, actually not equals to, plus 1 over 150 times q of t, the function, equals to 2. Something along this line, right? And you might want to apply something called Laplace transform, okay? Laplace transform. For example, apply a Laplace transform here. You can change this thing to, let's say, change this equation into another equation in terms of S. Well, of course, you need to be familiar with the table or whatsoever, okay? And there are some fancy formula, for example, like, S times Q of S minus, let's say, Q of 0, and then plus 1 over 150 Q of S. And that equals to 2 over S, something along this line. The next thing is Q of naught is your initial condition. You can use S times Q of S minus 5 plus 1 over 150 Q of S equals to 2 over S. The next thing is you might want to rearrange for this Q of S, like solve S times Q minus 5 plus Q divided by 150 equal to 2 over S. The Laplace transform of a constant is 2 over S, this variable, whatever variable it is, and then get a Q. So you get that expression. So Q of S is actually 150 times 5S plus 2 divided by S times 150S plus 1.
And if you divide both top and bottom by 150, you'll be able to get, let's say, 5s plus 2 divided by s, and then s plus 1 out of 50, okay? And then you could split that into partial fraction form like that. Something along this line, okay? And eventually, let me just save a bit time. Well, you will be able to get that, and eventually this thing will be, if you divided that by 150, you get a 295. So this A, for example, is 300, and then B value is, let's say, minus 295, okay? And the next thing is because Q of S equals to 300 divided by S, and minus 295 divided by S minus negative 150. Well, what I'm trying to say is Laplace transform is mapping an expression in terms of t into S. And then if you do the inverse Laplace transform, it will map back an expression of S back into an expression of t. So for example, now I take the inverse Laplace transform, like L inverse, you'll be able to get like 2 to 2 over S. So 300 over S goes back to, let's say, 300. And then this pattern will, map to minus 295. Whenever you have a fraction underneath like a S minus something, it must be an exponential function, e to the power minus 150 times t. So that's how you're going to use, Laplace transform to solve this differential equation. It's useful when you know the initial condition. When t equals to 0, what's the value of the function? Or what's the derivative, first derivative of the function, okay? So I just put my notes here. Laplace transform and inverse Laplace transform, okay? Hopefully my memory works. It's a bit vague from a long time ago. Anyway, going back to the question itself, if you want to find a quantity of salt in the tank to approach as time approaches infinity, basically, you can say t approaches to infinity, 295 e to the power minus 1 over 150 t approaches to 0. Therefore, your Q eventually approaches to 300 kilograms. And then you want to find the time of the quantity of salt in the tank to reach 100 kilogram. So you can just use, let's say, the result from previous part. You solve 100 equals to 300 minus 295 exponential minus t over 150 for t. And the question needs you to write exact value because it doesn't specify any rounding instruction. So 150 log e of 59 divided by 40 minutes. Okay. All right. When the quantity of salt in the tank reaches 100 kilogram, the tap draining the tank is turned off. Assume that the tank does not overflow and there is no change to the inflow rate. Once we turn off the tank, the tap to drain the tank, I would say the volume is just increasing. So now my volume of T, actually I should say volume of capital T. Capital T is from the moment, from the start of tap off, okay, number of minutes. V of T, well, when it reaches 100, at the moment it reaches 100 kilograms. The volume is still 3,000. But after that, each minute, I suppose, it increases by 20 liters. So we add 20 T here. The next thing is you need to know your, the amount of salt. So let's go back and look at the QD capital T now, because now you only have the inflow rate, which is 0.1 times 20, that is 2. Then Integrating this dq d capital T gives you q capital T is 100 at the beginning. You have 100 in the tank, kilograms, plus 2 capital T. So basically, your new concentration at a new time capital T is 100 plus 2T divided by 3000 plus 20T. And I want to figure out the amount of time to reach this particular concentration. Hopefully I'm correct. So that's 100 plus 2T divided by 3000 plus 20T equals to 1 out of 20, comma T. And you get a 50, which is a very lovely number. So T equals to 50 minutes after the tap has been turned off. Well, it's a very decent differential equation question on calculus. I like it. But of course, you're not expected to do that, okay? All right. Question 4 is a lovely, let's say, vector calculus question. For example, if you go up and look at a menu insert problem, you can actually add a graph first. In doing that, I'm trying to use, let's say, graph entry parametric. Now, I'll type 5 cosine of t minus 4 cosine of 5t over 2. And the next thing is 5 sine t minus 4 sine 5t over 2. Also, if you just, let's say, let it go, you don't actually get exactly the same thing here because the default t domain is from 0 to 2 pi. So it's not sufficient. Maybe I can just increase that slightly a little bit to 4 pi, like 2 complete cycles. So when you get 0 to 4 pi, you are able to see everything. And if you want this one to be more complete, you might want to use, let's say, 6 pi or 8 pi whatsoever. So what I try to do is use 8 pi to be more conservative so I can encompass everything. And write down the coordinate of the starting point. You can just define the function like r of t is assigned to x1 of t. Let me do that again, x1 bracket t, comma y1 bracket t. So it automatically turns into the vector function once you define it, and r0 is 1, 0. And on the graph above, draw an arrow from point 90. So where can you get 90? R of t equals to 9, 0, solving for t, control enter. If you look at the decimal approximation, it seems to be 2 pi, 6.28, like 2 pi. So let's try r of 2 pi. Yep, it arrives at 90. And I like to get the direction. Direction means the velocity. So you can define your v of t as derivative of r with respect to t. Oh, bear with me. That should be an r here. And I try to use v of 2 pi. So you get a 0, 15. Therefore, once you get, let's say, v of 2 pi, that is 0i plus 15j. It's only vertically upwards, pointing vertically upwards, okay? Hopefully they don't want everything to the scale. Otherwise, I would draw a vector triple long, okay? Probably like that. I don't think you have to do that. But anyway. So this is v of 2 pi equals to 15j, okay? Coming from this point 9, 0 for the velocity, instantaneous velocity. And find the value of t for which the particle will first return to this starting point. Well, basically you use, in my previous videos, I always talk about the lowest common multiple where you find a common period between two circular functions. This thing applies here. Looks like I'm going to say the period equals to 4 pi. Therefore, your t first equals to 4 pi, okay? For example, if you try to get, let's say, 1, 0 here, see, 0, 12.56, 4 pi, 12.56 something, okay? This is my answer. Next thing is show that the speed of the particle, and part E is the maximum speed. You can finish part E first, like the maximum speed equals to, when this cosine thing is -1, you will get the largest possible value under the square root. That is 125, actually plus 100. So you get a square root 225. And I believe that is 15 meters per second. So you can get that down easily. But to show the speed, you probably need to get a VT here. A V of t is like that. And then, because the question has 3 marks, you probably need to pay a bit more respect to a 3 marks question, like showing sufficient amount of working. Anyway, I will get, for example, the velocity vector first. So this guy is 10 sine 5t over 2 minus 5 sine t times I plus 5 cosine t minus 10 cosine of 5t over 2 times j. The next thing is I want to work out a speed. So it's a square root of something. 10 sine of 5t divided by 2 minus 5 sine of t squared plus 5 cosine of t minus 10 cosine of 5t divided by 2, whole thing squared. The next thing is I need to show, because this is a multi-marks show that question, I need to show how I expand everything. Maybe later I need to collect some like terms using some trigonometric identities. So I have 100 sine squared 5t over 2, that's a squared, minus 2ab. So that'll be 10 times 5 times 2. That's 100 sine of, it was me, 5t times sine of t. And don't drop out the last term. That's a 25 sine square of t, which is a b squared. And repeating the same thing for the second perfect square, you will get a 25 cosine square of t minus 100 cosine of 5t over 2 times sine of t. And you still add 100 cosine square 5t over 2. So that's basically everything. From the first perfect square, you get 3 terms. And the second perfect square, you also have 3 terms. The next thing is 100 sine square, 100 cosine square. Basically, you get 100 sine square 5t over 2 plus cosine square 5t over 2 in the bracket. Also 25 sine square plus 25 cosine square is obvious, that's a 25. The next thing is I'm going to take out a minus 100 from the product of sine and a product of sine. Oh, I picked out a mistake. This is a cosine t, isn't it? So now I should have, let's say, a cosine of 5t over 2 times cosine of t plus sine of 5t over 2 times sine of t, something along this line. I have a square root, very long square root. So eventually you get a 125 minus 100. Now this pattern is cosine A cosine B plus sine A sine B. Basically, this is a compound angle formula, so you can write it like cosine of A minus B, which is cosine 5t over 2 minus t. And that falls out nicely. 125 minus 100 cosine of 3t divided by 2. All right, so that is 3 marks question. Takes quite a bit of work to explain, but eventually, if you are judicious and careful enough, you'll be able to get the 3 marks, I suppose. Then, second last part, you want to trace the path of the particle from 0 to pi. So I'm going to use my cast to facilitate a little bit. I don't want to reinvent the wheel, but x1, x2, y1, y2, we are drawing a new graph. over the old graph. So x1 of t, y1 of t. The only difference is I'm going to use a 0 to pi rather than 0 to 4 pi or 0 to 6 pi, 8 pi, etc. So now you can see the direction is like that using the red curve coming from 1, 0 and hopefully ending up, I can double check, r of pi. The end point is -5, -4. So yeah, so this is what I'm gonna trace. So I'll be using the purple color beaker. So from here, it's 1, 0, and I carefully trace. Oh, carefully trace what I have on the booklet. I think it's up to here. -5, -4. Okay? T equals to 0 and t equals to pi. Direction, something along this line. Okay? Anyway, so that's pretty much what I need for the second last part. And I finally find the length. This is just integrating the speed. So arc length equal to, distance from 0 to pi. 0 to pi, square root 125 minus, let me write it properly, 125 minus 100 cosine of 3t divided by 2 under the square root dt. I can just do, let's say, norm, whatever it is, norm v of t, yeah, t collect, norm, yeah, like that, integrate, integral, that, and 0 to pi. Yep, 36.6078, blah, 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 rounded to 36.6 meters. So the problem is solved. And let's have a look at question 5. Find a point of intersection between the three planes, vector lines equation question. Menu, insert the problem, well, get a calculator. Menu 371, 3 equations. 2x plus 9z equals to 8. 3x plus 6y plus 5z equals to 7. X plus 9y minus 3z equals to 7. Yep. So you get a -5, 2, and a 2. Find a vector that gives the direction of the line of intersection between pi 2 and pi 3. So to find the line of intersection, you need to either use the cross product between that normal vector and another normal vector. That is one possible method. And then because -5, 2, 2 is a point of intersection between 3 planes, it definitely lie on the line of intersection between, say, these are the 2 planes, and another plane is like that. So eventually, it's cutting here, okay? Suppose you're finding the direction here. You choose -5, 2, 2 as a reference point, and then use the direction vector. But you can also just copy and paste the first entry. And for example, you give any letter a parameter, say x equals to t. Then you'll be able to get that. For example, putting x equals to t belongs to R. We call it 1, 2, and 3. And solving with 2 and 3, we get x equals to t, y equals to 8/9 minus 2/9t, and z equals to 1/3 minus 1/3t. Therefore, the direction vector of L equals to 1i minus 2/9j minus 1/3 k. I mean, the 3 components here must have some kind of, coefficient, or let's say ratio.
if you set y equals to t, you pretty much get, let's say, -9/2, 1, and 3/2. And if you multiply this thing by a 9, you get a 9 minus 2 and a minus 3. So it must follow that ratio, 9 to 2 to -2 to -3, etc. But actually, the question says find a set of parametric equations that gives the coordinate of the points that lie on this line of intersection. You can just reuse your previous part, okay? Of course, if you take a cross P between 3, 6, 5, comma, 1, 9, -3. -63, 14, 21, they're all multiples of 7. So if you divide it by, let's say, -7, see, 9 minus 2 minus 3. It must follow that ratio. Very simple. Again, just want to reiterate what I've been saying. Part of B1, part of B2, they have an infinite number of answers, okay? All sorts of possible answers. So this is an interesting question. Find the shortest distance from 1, 1, 2 to the plane pi 3. So pi 3, we have, for example, x9, 1 minus 3 z equals to 7. X plus 9, 1 minus 3 z equals to 7. For example, if I set y equals to 0, z equals to 0, it leads to x equals to 7. So let's call this Q, whatever. Oh, actually, call this one P, okay? And the Q is 7, 0, 0. So now I should have a Q to P equals to, let's say, minus 6i plus 1j plus 2k. Say this is Q, this is P. You have a normal vector. You want to find the shortest distance. You need to take, let's say, a scalar resolute of QP onto n hat, okay? So the shortest distance equals to QP dot n hat, n3 hat, okay? I'll just clarify. n3 equals to I plus 9j minus 3k, something along this line. And then I can just use my CAS calculator, dot p. -6, 1, 2, comma, unit vector 1, 9, -3. And don't forget, you need to turn this into, let's say, a positive quantity. It's not okay to just write -3 over root 91, then followed by equal to 3 root 91 over 91. Be consistent. That's why you need absolute value sign here. Okay, another family of planes. Is that a phi? Actually, how do I pronounce this Greek letter? Don't know. Anyway, so this equation has let's say the normal vector of this thing is, let's say, 6i plus 27j, and n1 equals to, just read that off from the first equation, 2i0 up. It doesn't have, let's say, j component. I should write, let's say, 27k, and n1 is 2i plus 9k. Because their normal vectors are parallel to each other, n phi equals to 3n1. Therefore, n phi or whatsoever parallel to n1, and phi parallel to capital pi 1. Now, because these two planes, or one of the members in this family is parallel to pi 1, we want to figure out the shortest distance. Actually, the shortest distance is given to you. So the distance between two parallel planes, pi 1 and a capital phi whatsoever, equals to the difference between their constant divided by, let's say, the magnitude of the
normal vector or whatsoever. So we have 6x plus 27z equals to m. Also, if you refer back to the previous page, they are in a certain ratio, but the coefficients of x, y, z don't match. I have to multiply 3 here. So 6x plus 27y equals to 24. Something like that. 6x plus 27z equals to 24. So in the top bit, I'm going to use m minus 24 in the absolute value because I don't know which one is higher, which one is lower. I have to use absolute value to make sure it's a positive distance. The bottom is just 6 squared plus 0 squared equal to 27 squared. Something along this line. Today my Apple Pencil is a bit laggy, but anyway, doesn't really matter. Just to write that properly. And this one should equate to 23 divided by 3 square root of 85. So eventually, I can just solve this equation, but don't forget I need to use absolute value, m minus 24 divided by square root of 6 squared plus 27 squared equal to 23 divided by 3 square root of 85, comma m. So you have m equals to 1 or m equals to 47. Okay? Something along these lines. Anyway, this is question 5. Then I'm going to quickly walk through question 6. Write down the mean and the standard deviation of the sampling distribution. So V bar is normal distribution. Follow the same mean value 1,000. How many do I have in the sample? 25. So you get 80 squared divided by 25. Therefore, the expected value of V bar equals to 1,000. And the standard deviation is 80 divided by 5. 16. Something along these lines. What is the probability corrected for decimal places that average volume consumed by random sample 25? Yep. This is using the sampling distribution in part 1, more than 970. So norm CDF, 970 up to infinity, 1,000 and 16. So we say probability of V bar greater than 970 equals to 0.9696. Something along this line. Okay, the canteen at a particular school stocks 2 brands of watering bottles, Wasser and Upper. The manufacturer of Wasser bottled water knows that the volume of water dispensed into bottles may be assumed to be normally distributed. Standard deviation is 5, sample size 30, sample mean 750, 95% confidence interval, 300 samples, 300 confidence intervals times that. It will capture how many capture the actual mean. So 300 times 0.95. 285. Okay, part B and part D, I need to use CAS. Part B, menu 661. Stats, sigma is 5. X bar is 750 times 330. Data value, C level is 0.95. Okay, control enter. 782 point, actually, the other way around, 748.2, comma, 751.8. For the confidence interval, make sure you copy the digits carefully in the correct order from smaller to larger, okay? Minimum sample size, distance difference between the sample mean and the mean volume dispensed is no more than 1 margin of error. So 1.96 times 5 divided by square root of n, less than or equal to 1. Or actually, you can use 1.95996 times 5 divided by square root of n. I don't think it makes an awfully lot difference. So you get n greater than or equal to 96.03 or 04 something, and the smallest integer is gonna be 97. Okay. Hypothesis testing, one-tail test, 1% level of significance. The company claims that the mean volume of water dispensed is less than 750. So H naught is mu equal to 750. H1 suspicion mu is less than 750, one-sided. Determine the p-value. The sample mean is 748. It has changed, so don't use the same sample mean value as before. 671, you get a stats here. Mu naught 750, sigma is 5. X bar is 748, m value is 50. Alternate hypothesis for less than. Okay, control enter. So the p-value equals to 0.002338. So round it to 0.0023. 4 decimal places, suppose. Let me double check. 1 decimal place, yep, no problem. Is the company's claim correct? Because p-value is less than 0.01. We have very strong extreme evidence to reject H naught in favor of, let me write it properly, in favor of H1, which is sort of accepting H1. If I accept H1, I should trust the claim is true. It's indeed less than 750. Yes, their claim is correct. All right. Sample mean value below which would support the conclusion is now less than 750. So we want to have, let's say, the critical value. This is C star. This is 0.01. I want to get inverse norm. 0.01, 750 is my claimed population mean value. Standard deviation is 5 divided by square root of 50. So my C star is 748.355. Last part after the service, the true mean is 747. Well, this is 750. So if I draw an identical curve but at a different mean value, this is gonna be 747.5. Find the probability that the company will conclude that service has not reduced, which is like accepting H naught. So we are going to find, let's say, type 2 error probability under the new curve on the right side of the C star. So I'm going to use norm CDF. Now I'm using answer here as my lower bound to infinity. And 747.5. But the standard deviation is still 5 divided by square root of 50. Okay, 3 decimal places. 0.113295, etc. Rounded to 0.113. Just be aware of rounding. If you rounded this thing too early, your answer might not be accurate. So if you use 355, you still get a 0.113. But if you use, let's say, some incorrect value like 36, you actually get a 0.112, which is one off. And it's not ideal, okay? Well, that is my quick walkthrough to this section B of the Specialist Maths Exam 2. That's just for my historical record. Hopefully you find this video helpful at some stage. I'll see you in the near future. Bye.